Welcome everyone to another Khan Academy tutorial. We're doing the advanced version of multiply and divide rational expressions. There's a basic and there's a regular version. Made really small mistakes in both of those, so check out those videos, learn from my mistakes. But anyway, we're gonna go fast in this one. So hopefully you need to watch those other videos and complete those other Khan Academies before getting to this one. So let's go ahead and get started. First thing I'm gonna do, I recognize it's multiplication, so I can go ahead and reduce this. I can factor that. So I'm going to factor it into two parentheses where it's going to be k and k, and then I'm going to have 7n and 7n plus and plus. So essentially that's 7n k plus 7n squared, but I'm going to leave it like that because I might be able to cancel it with something a little bit later. That's my first fraction, my first ratio. I'm going to move on to the second one right here. I recognize immediately difference of squares in the top, so I'm going to write k, and then I'll write 7n and 7n there. One needs to be positive and one needs to be subtracting. In the bottom, I can factor out a 4, and that's all I can factor out, and I'm left with k minus 7n. Now, this is the fun part. I get to cancel. So anything I see in the top, I can cancel with the bottom, so I get k plus 7n cancels, k minus 7n cancels, and the 4's cancel, so I'm left with 1 over k plus 7n. Final answer. 1 over k plus 7. Got to hold it down to get the n. Double check. Check it. Next question. Doing great so far. The following equation is true for all real values of z, for which the expression on the left is defined, and b is a polynomial expression. What is b? Ooh, this one's a good one. So, first thing I need to do is I need to keep, change, flip. I'm going to change this into a multiplication problem. So I have 5z squared over, let me factor out this z real fast, z, and then I have z plus 5. So I want to do that, factoring this. Now I'm going to change it to multiplication, and I'm going to flip this other fraction right here. So I'm going to put b in the bottom over, and I'm going to factor this guy in the top. Okay, this I'm going to factor. And that's z. And then I need factors of -5 that add up to -2. That's going to be -7 and then +5. Okay, so what I'm going to do here is I'm going to cancel what I can. I'm going to cancel one of these z's with one of those ones. I'm going to cancel the z plus 5 with the z plus 5. And I'm going to need to rewrite this as 5z, z minus 7 over b equals 1. And I'm going to write it as 1 over 1, and you're going to see why in just a second, because I'm going to cross multiply and solve for b. So I have b equals 5z over z minus 7. Okay, and that's it. So I could just write that expression. I'm pretty sure I can just leave it like that. I don't think it needs it in expanded form. I can leave it in factored form. So let me write 5z, z minus 7, 5z times the quantity z minus 7. We're going to double check it, and that's it. Let's check it. All right, good. That was technically a triple check. Divide the following rational expression and simplify the result. This one's almost easier than the regular, but maybe that's just me. Okay, I'm eating my words as soon as I look at the top fraction. You can hear me get my calculator out. So I have here 63n squared. I'm looking at this first ratio here. I want to know if 168 is divisible by 63. That one's not off the top of my head. It is not. Okay, but they do have a common factor. They got to. Okay, 1, 6, and 8 add up to 15, and that's divisible by 3. So I know they're both divisible by 3 at least. So I know I can factor out a 3 in the top, and I'm going to be left with, what's 63 divided by 3? Maybe they're both divisible by 9. Let me try 168 divided by 9. Divided by 9. It is not. Just my luck. So 63 divided by 3 is going to give me 21. So I have 21n squared plus 168 divided by 3 gives me 56. Okay, 56, 8, and 7. So really I had a factor of 21. I'm almost positive 168 is divisible by 21. Yes, it is. Okay, so really I had a factor of 21. The reason why I could figure that out is 7 and 3. 7 is factors of the inside. I already factored out a 3, so 21 is going to be a factor. Okay, just some verbal thinking for you. So I'm going to factor out 21, and I get 3n squared plus 8n. what am I doing? I can factor out an n. I totally missed that both of these have an n. So I'm going to factor out an n also, 21n over, all right. Now what can we factor on the bottom? We can factor out a 7. And I think that's it, because we're going to get 8n minus 3 there. Okay, keep change flip for this. We're going to change this into multiplication, and we're going to flip this guy. So we're going to write the top part up here, 64n squared. Okay, let's try to factor this. We're going to factor this top one right here. It's on the bottom, but it's going to be on the top. Okay, 2 parentheses. They don't have any common factors. 64 isn't divisible by 3 or 9. I'm guessing 8n. Let's try 8n and 8n. And then maybe it's 3 and 3. Now, how do I check this? Well, I'm going to FOIL, but I only really need to FOIL the outside ones. And I get 24n, and I get 24n. Okay, I just need to make both of them negative, and that will add up to negative 48. So minus, minus, and I got that factored. This one, this top one, which is really the bottom one, is going to be difference of squares. So I have 8n plus 3, and then 8n minus 3. Best part, I get to cancel. One thing I'm going to do here is I'm going to switch this 3n plus 8 to 8 plus 3n. No, I'm going to leave it like that. That one's a trick, and I'll talk about that in just a second. 21, and I'm just going to double check that. Yep, 3n. Okay. So let's cancel. So we have 8n minus 3 is going to cancel with, let me use red. 8n minus 3 is going to cancel with that 8n minus 3. This 8n minus 3 is going to cancel with that 8n minus 3. And the temptation is to cancel this 8n plus 3 and with that 3n plus 8. That's a trick. Okay, you can't cancel that. So don't do it. We're just going to write our final answer of, we can cancel the 7 with the 21, leaving us 3. So it's going to be 3n times 3n plus 8 over 8n plus 3. Okay, and that's going to be our final result. So 3n times 3n plus 8, 3n times 3n plus 8. And then, oh man, I forgot to put that. Oh, look, you can just type it in and it puts the fraction in for you. That's really great. 8n plus 3. Double check it. Okay, really long problem. Hopefully we got it. We did. Whew. I was kind of holding my breath on that one. Last one. Let's see if we can do it fast. But not furious. Okay, fast, not furious. Top one on the left. We don't have to keep change flip here. We're just going to go top one on the left. We're going to factor out 3n squared. And we're going to be left with n squared minus 4x squared. Ooh, that one's cool. All right, bottom. We're going to factor out 4nx. What are we left with? We're left with 2x minus n. Okay, so we got that one done. Moving on to the right one, times right one, negative 8x. That's going to stay. And we have 2 parentheses here. And it looks like we're going to have n. We need factors of negative 8 that add up to negative 2. So that's going to be minus 4 plus minus 4x and then plus 2x. And I think that's it. Okay. Double checking. Now, one thing you'll notice here is we can rewrite this guy as difference of squares because both of those are squares. So we're going to rewrite that. I'm actually just going to erase it to save some space and time. Oh, let me see. I need to n squared minus 4x squared. So it's going to be n plus 2x. N plus 2x. Let me go here. N plus 2x. And then n minus 2x. We took the square root of 4x squared. And we took the square root of n squared to get those two terms here and here respectively. One's negative, one's positive. Cross canceling, best part. We get to cancel the n plus 2x, n plus 2x. N minus 4x doesn't cancel. We can cancel this negative 8 with that 4, leaving us negative 2 up the top. We're going to cancel that x with that x. We're going to cancel this n with one of those n's. And I think that's it. We're going to be left with 3n times n minus 2x in the top, and then n minus 4x in the bottom. And I forgot the 2x minus n. 2x minus n. Okay. This is a move that's pretty cool. So I forgot about this. 2x minus n. Okay. Now, what I can do here is I see that these are opposites. So what I can do is I can factor out a -1 from one of these. So what I'm going to do is I'm going to factor a -1 out of the top one. So I'm going to make it -3n. And how does that correct it? We're going to divide each of the one of those by negative. So it's going to be a -n plus 2x. Sorry, 2x over 2x minus n times n minus 4x. This is actually a really good one to end on. Okay, now I'm going to rearrange the top one again to get -3n times 2x minus n. And now I have 2x minus n in the bottom, and then n minus 4x. So you can see, once you see that you have opposites like I showed highlighted, you can factor out a negative to make sure that they're the same. So now we can cancel them completely, and now we have a much more reduced problem, -3n over n minus 4x. -3n over, what is it, n minus 4x. n minus 4, hold it down to get the x, check it. Oh no, what did I screw up? Has to be something somewhere small. Oh my gosh, this is the worst. N minus 4x. That's what was left, right? N minus 4x. Oh gosh. N minus 2x. Oh, I forgot to multiply by that 2, didn't I? Take a look. Right here, I had this -2 that I totally forgot about. Totally forgot about him. So technically, this should have been multiplied by -2. So then when I pull out a negative, I still have to multiply by that -2, and I get positive 6n over n minus 4x. Whew! Positive 6n over n minus 4x. Check it again. There we go. That makes me feel better. So hopefully, a lot of steps. I haven't gotten one perfect yet, but that's the nature of Khan Academy. It'll definitely make you better. Hope you enjoyed this video. Look forward to seeing you next time on Wes Explains Best.